Hello, everybody. We are Team Velvaere. We are trying to bridge the gap between postpartum depression patients and the doctors. We have a team of 4 people: myself, Savita, John, Hand, Oren Karmali, and Judy Lee. We all are part of Capstone team of MITS.
To provide a quick background, postpartum depression is defined by 2 or more weeks of persistent depressed mood or a loss of interest in daily activity, which onsets within 4 weeks after giving birth. The problem that we've identified is that there's no specific test for diagnosing PPD, and it's currently observed in 10 to 15% of new mothers. However, there's a lot of cases that aren't recognized, so this suggests that current methods of screening are insufficient. So we want to work on addressing this problem because better diagnoses will help with mother and baby safety and well-being. The solution that we're sharing with everyone today is a web-based app called Bridges, and this will improve diagnostics for depression by generating predictions based off of survey data and fMRI brain images. The target users for Bridges are women who have recently given birth, as well as healthcare providers who will be able to leverage our prediction results to support decisions in diagnoses.
So our Bridges solution is a two-part solution, like Julie just said. The first part on the left is going to be a patient portal where the new mother or physician can suggest starting a new depression screening survey. And then that survey will then be classified as likely to have depression or not. And based on that, at the doctor's discretion, they can then do a fMRI, which will be the part 2 on the right, which the physician will initiate an fMRI, and then they will upload that fMRI to our portal, and then a image classification model will determine whether or not that fMRI is likely to be depressed or not depressed.
So here's the website that's intended for patient use. We populated the homepage with an introduction to our product, why improving PPD diagnosis is important, and also how to navigate our website. And if we go to the About Us page, we provide an introduction to our team, as well as some additional information about the data that was used for both the survey model and the imaging model, as well as our group's mission statement. And we also have a sign-in page here that allows new users to register and also returning users to sign in. And here is our modeling page. It consists of 31 questions that were either identified as features or can be engineered into features for our model. And after completing all of the questions, the users will submit their responses. And for the sake of time, I have here a pre-populated survey. And so if the user clicks submit, they will receive a prediction that this person is not likely to have postpartum depression. And then we also have a depressed example where the user will receive a prediction saying that they are likely to have PPD, and we recommend reaching out to their healthcare provider for next steps. And we also included a privacy policy, and this details what data is collected, how it's used, and the user's rights to their data, and etc. We also have a contact page where users can submit questions or requests to our team, and also a community page that allows users to connect with other mothers who may be navigating similar challenges related to postpartum. So I'll stop sharing for now and let Savita go into the imaging model demo.
Thank you so much, Judy. So I'm going to share. Can you all see this page?
Yep.
So this is our second model. Like John said, it's a two-part solution, the Bridges. This particular solution is meant for the doctors, and they can upload fMRI, and it gives you prediction based on that fMRI. So it has all these sections. The very first one I will go to is upload an fMRI. So they can browse, they can pick an fMRI, and they can upload it. And at this time, it is running that data pipeline. It picks up each and every image, 3D image, breaks it into each one of the dimensions, looks at the signal strength and see whether it is worth keeping or discarding. And now it has created a pipeline in 4.09 seconds. Now, using that set of data, we can now run the inference. Now, in the inference, each one of those images, it passes through the deep learning computer vision model that we have created using efficient P0. And it starts predicting each one of those images, whether they are markers for depression or not. And it starts creating a cumulative counter for it. So based on that counter, it feels that this particular fMRI is about 97.89% depressed individual. So it is about that much sure that this person has depression. Now, like any other doctor, I guess, and our doctors would like to see individual pictures of the brain, so they can go to the view inference detail and start looking at these brain images. So from each one of those dimensions, it picks up these images. I am only showing you about 5 images, but this for MVP, but this model can be extended to any number of images that that particular fMRI has. Now, after looking at this image, how did the model decide that this particular image shows some kind of depression? So let's take a look at how the model decided. So here is the heat map of for that particular image. So if you start scrolling down, you'll see that each one of the layer of that neural network, it starts looking at some section of the image and starts putting a heat map on it. And here, these are the markers that it found to have depressive behavior. So each one of those things. So doctors, of course, can take a good look at these and can definitely decide that these people definitely show signs of depression. Now, apart from all this, the doctor can download all these inferenced data and they can save it on their own laptops or desktops or whatnot. So the CSV is there, and that is pretty much it for our demo. I will give you one more demo, which is for the healthy individual. So I have another fMRI, which is not depressive. It's a healthy individual. So let's see if it is able to predict it. Again, it ran through the pipeline 4 seconds. So I'm going to run this inference. Each one of those images will go through this pipeline to see whether this particular image is. Now, I know this person is not depressed, but then when an fMRI is uploaded, of course, it is not known whether the person is depressed or not. So this model will go through it and it will do its prediction, and let's see what it says. All right. So according to this model, this individual is not depressed. It is 96% healthy. And like the previous time, you can go through individual images here and pick and choose any image and do a deep dive into those images and, of course, download the result. So that is all for our demo. Thank you so much.